Hey folks, welcome. We are in Summer School Mathline again. I'm Ernie Roberts. I'm your host for TNLearn's Mathline, the summer school version. You know, we love this time of the year. Living is easy, we take it easy, and we're going to do the same way in the Mathline. But you know what? We've still got some good things to come your way today. What you might want to do is get you some paper, get some pencil, and let's sit back, let's relax, and you know what I love to do? Let's do the math, all right? So we're going to do today, speaking of which, our summer school today says apply with care. And you know, this is all about applications. This is what we do math for, is so that we can translate to English situations, to verbal situations. You know, you put it in from, as we say, words, English, verbal, into the math symbols, all right? That's what today's going to be about. So sit back, relax, and let's do it, okay? Let's see what our first situation is going to be that we're going to look at. Oh yeah, we just want to review a little bit here. We want to think about some words that indicate that addition is needed to solve a story problem, all right? As I said, that's the whole game today, is that we can take the math symbols and apply them to what we're reading, all right? That kind of thing. So let's see. First of all, some words that we might read that indicate we're going to do addition. Well, besides addition, some of you say, well, what about addition? I guess, yeah. But how about the word, we love that word plus. We say 3 plus a number. 3 plus x, all right? Another one, the sum. That is the result, okay? How about total? Total works for us also. Increased. Or increased by, all right? Sometimes we put a little preposition on the end of these words, all right? How about more than? And greater than while we're at it. And like I said earlier, how about it? We love these phrases. How about it? We get added to, all right? Those are just some of the words. There are others, some that get real fancy and big and long things and stuff. But the idea is that we're indicating that things are increasing, they're getting larger, and these are all the great terms that will take care of us on that, okay? So that's our first one there. We got addition. Let's take a look at our other operations that can come in place, because there's 4 of them altogether, right? Let's talk about subtraction, what we need from subtraction to solve a story problem. Well, you know, with plus, the opposite is minus. We know that one. We hear that. We also hear the word difference, because that's the result of what we get when we subtract. So you hear that word difference, that means we're into subtraction, all right? The other words that you might hear, how about it? Less. And then there's also less than. Now you say, what's the difference, Ernie? Well, less means you're going to read this thing left to right. So if I say 9 less a number, that would be 9 minus n. But if I say 9 less than a number, that would be n minus 9. So it makes a difference. This is almost like you switch the order when you hear less than, all right? So just keep that in mind, because we're going to see an example or two from these later on in the show, all right? Reduced by, those kind of expressions. Decreased for the opposite of increased. How about it? Another word, diminished. Told you we get some fancy words on Mathline. And then perhaps we say subtracted from. So those are some expressions. Those indicate we're going to involve subtraction, all right? So there are the first 2 operations. How about it? Multiplication and division. Let's take care of those also while we're at it here. We're wanting to select some words that indicate multiplication or division to solve a story problem. Well, the big one with multiplication, we're going to put these together, all right? We'll put multiplication on one side and put division on the other. But first, with multiplication, the word times, we hear that 5 times a number or 3 times a number, all right? Those kind of things. That is like 3n or 5n, all right? The other one that we would have would be product. That's the result when we multiply things. The word product indicates we're in a multiplication mode, all right? Another one, twice, all right? Of course, someone says, what about thrice? Well, you know, you get the idea. But twice means 2 times something. We can also play with the game double and triple. You can get on, you know, from those. And then sometimes we see the word of, like we're saying, what is 4/5 of a number? That would mean 4/5 times n. All right, so those are some important little things to do with multiplication. All right, those are keywords to look for. They indicate those type things are going on. Now, the division, not so many. Obviously, the word divided by and quotient. And not to forget, if we have, we take a third, and you get the idea. We could do a fourth, through all sorts of good things. So that indicates that we're dealing with division. In other words, when we take half, we're dividing by 2. When we take a third of something, we're dividing by 3, and we can continue on and on. So those are some of our terminologies, just to refresh your memory, all right? So again, not the most exciting thing to start off with, but essential, because we want to make sure that you can handle the vocabulary and change it into one of the operations, because that's what it's all about. That's what it's all about, taking words and making symbols happen. So let's read our first problem here. Let's take a look at, let's get into some real stuff here. It says the sum of twice a number and 9 is 15. What is the number? Now, keywords here. I see sum, I see twice. The and tells me we're joining twice a number and 6, and then we're going to add 9 to get 15, all right? Is, by the way, is our equals point right here. So the sum of twice a number and 9 is 15. You say, Ernie, what are we going to do? We're going to first of all say something has to represent, what are we looking for? We're looking for the number, all right? So we're going to let that be, I'm going to let n be the representation, since it's just a number we're looking for. So we always want to define our variables here, all right? So n is going to equal a number. And you know, it's kind of nice we use n because the word number begins with n, all right? So just a nice little phrase to use there. Twice a number, all right? First of all, let's go back and think. Twice a number means we're multiplying, correct? So we're going to say 2 times n, that's twice a number, and 9, all right? So we're going to add 9, because that's kind of what the and is all about. And it says we're going to have a sum of that, okay? Let's keep going. Is, that's your verb. There's your equals right there. And what is it equal to? It equals 15. So again, we get the left side, the right side going, and it's separated by that lovely verb is for our equals. Now, game plan. These look familiar. Let's remove, we need to move the 9, we need to remove the 2. All right, so let's first of all get rid of the 9. We're going to subtract that from both sides. And we're going to have that little subtraction property of equality running in our name here. And I don't know why I just did a -6. Let's make that -9. And you know why I made it a -6? Let me tell you why we made it a -6. Because I was thinking ahead, not with a negative involved there. Oh, we'll make that prettier. I just looking kind of crazy there. All right, -9 looks worse, doesn't it, folks? Well, let's move on. We've got 2n on the left equaling to 6 on the right. That's what we're looking for. So let's see what this number is going to be. Number is going to be 3. Now, we do want to go back and check. Make sure this makes sense. And we're going to say twice a number, which is going to be 2 times 3, which is 6, added to 9. It gives us a sum of 15. So it does check. You can do a mental check. You could also have written that down. And again, barring my little unforeseen problems there, we do get a nice good answer. But remember, we're going to subtract that 9 from both sides, and that kicks us right on through the problem. Okay? So, off to a good start. We do believe we are. We're off to a good start. Let's see where we're going from here. Our next problem here says 36 less than 4 times a number is 8. What is the number? Now notice I highlighted, and I'm going to even underline it after we've highlighted it. I highlighted this less than because I want us to understand what are we going to do with this. Remember what we said, when we do less than, it makes things go in a reverse order. So what's going to happen here? First of all, let's name our number. We'll call our number n. And we're going to kick along here, and we're going to say it's not going to be 36 minus 4, folks. It's going to be 4 times the number. And we're going to subtract 36, because that's what we do with less than. That's what we do with less than. We bring this part to the front, and we move the 36. The 36 is on the end of the minus, okay? Equals to 8. There's our story. That's our equation, ready to go. Now, from here, we're going to add 36 to to both sides. And you know what? We are going to get 4n equaling to 44. That was easy. That was easy. Now, how you say, Ernie, what did you do? We added 36 because that goes away, right? And then we add 36 to 8 over here because whatever we do to the left side of the equation, we got to do it to the right. And so that gives us the 44. Kicking through, we now have n equals to 11. Good news is 36 less than 4 times the number is 8. So remember, what are we doing? We're saying 4 times the number, which is 4 times 11. Subtracting that 36, yes we do, because 4 times 11 is 44. All right, so it checks out back through. Always looking to make sure we don't make any bad mistakes or errors there, right? Okay, now let's take a look at our next one. Ooh, you say, Ernie, that looks like the same problem with one exception. I highlighted only one word because there is not a less than here. So here what we're basically saying is 36 less 4 times the number. That's just like saying 36 minus 4 times the number is 8. So we're going to let n once again equal our number. That's good news. That's good news, all right. And this time it's not going to be 4n minus 36. It's going to switch. So it's going to be 36 minus that 4n, which will give us a result of 8. Now, folks, I'll go ahead and tell you, guaranteed, it's going to be a different answer. All right, it is going to be a different answer because we switched this 36 and 4n in place. So it is definitely going to have us a different answer. Let's see what happens with this one. We're going to remove the 36. Now, whatever you do, stop the presses right here. Do not say 36 minus 4. That's a no-no. All right, you've got to go to this 36 first. All right, so we're going to move that 36 by subtraction because it's a positive 36. And over here, we're going to also move that 36 by subtraction. There we go. You see where we're going? Everybody with me? Hang in there. Now, the 36's go away. We're left with a negative, and by the way, make sure that negative slides in with the 4. Got to make sure of that. On the other side, we're going to subtract. It looks like 36 minus 8. And you know what I think I get? I get 28. Check me on that. And it's going to be a negative 28 because that absolute value of that negative 36 is a good bit larger than the 8. All right. Let's do it. Let's go for it. Let's divide negative 4 into the negative 28 and see what happens. I believe we're going to get the n equaling to 7. Now, is that true? You say, well, Ernie, let's see. Let's check. Put the 7 right back in here. Put it right in there, and I'm going to say 4 times 7 first because my dear Aunt Sally says multiply before you subtract, all right? So let's do that. Let's do the multiplication. That's going to be 4 times 7, which is 28. And I'm going to say 36 minus 28, does it equal 8? It does. It does. So this answer does check out in a good way, All right. Hey, we're just looking at applying with care, and we got to be careful. We got to be careful how we apply these numbers and these words, especially in the order we put them down with subtraction. Now, you say, if that had been addition, wouldn't have mattered. No, it wouldn't matter. But with subtraction, that less versus less than makes a big difference, all right? Makes a difference, makes a difference. Trust me. Notice we had 2 different answers completely entirely. So let's take a look at our next problem. Let's take a look at our next problem here. We've got the length of a rectangle is 5 centimeters greater than its width. If the perimeter is 46 centimeters, what are both dimensions? Mouthful. It's a mouthful. I even drew you a little rectangle to help us get started here, all right? Now, we usually think of the length being horizontal and the width being vertical, and according to this picture, and according to the instructions on the problem, the width is going to be shorter, all right? So I'm going to put a W right there to represent the width, and according to this, our length across the top is 5 more than W, all right? Now, be careful on that. So we're going to put W plus 5 right there across the top, all right? Everybody's looking? Everybody's good. Now remember things with a rectangle. The lengths are both the same here, all right? So this is also W plus 5. And of course, little w going over here. Now, a couple of ways we can do this. A couple of ways we can work through this problem, all right? Hang with me. We can add all 4 sides together, or we could double and add them together. It's going to give us the same result. Now, one other thing, before we go any further, let us make sure we have said W is equal to our width, okay? Our length is going to be 5 plus W. All right, so we want to keep that straight. So, okay, let's see what happens when we start working this together. Now, I'm going to use it with just adding all four sides together. So we're going to pick up W plus 5 plus another W plus W plus 5. Whew, did we get them all? 1, 2, 3. I count 4 W's there, and I count 2 5s. That looks good. And according to this, it says we're going to be equaling to, y'all ready out there, 46. You said, well, Ernie, that looked easy. A picture makes things very easy to work with. And in a rectangle, you just simply add all these together. You've got it going, all right? And let's see what's going to happen. We're going to add our W's, and we got 4 of them. 4W plus 10 equaling 46. Everybody with me? Y'all got it? Now, from here, let's pull it out over here a little bit. We've got 4W plus a 10 equaling to 46. And what we want to do, we want to remove that 10. So let's get rid of it. Subtract 10. And you know what we've got? We've got 4W left over. Now remember, we're going to have to subtract 10 from both sides. Good old subtraction property of equality hanging in there for us. And that gives us 36 to the right. And that's an easy equation. Divide 4 into 36. W is equal to 9. Now here's where things really work. Or hopefully they'll really work. All right. We're going to put 9 in for W. And we're going to say 9 plus 5 gives us 14. That's the question. We're looking for the dimensions, all right, both dimensions. Well, there's your width. It looks like it is 9. The length is going to be, and that's going to be W plus 5, is 14. The question is, if we multiply this by 2 and this by 2, will these add up to 46? Well, let's see. First of all, 9 times 2, that's going to give us 18. 14 times 2 is going to give us 28. I add those together, I count 46. It's a good answer. It's a good answer. So that's what we want to check here. Remember, there's 2 widths and 2 lengths. How do we get that length? I put an L there for the length, but you know what it is? It's actually W plus 5. So that's where we get the 14, and it happens twice. There we go. Answer checks out very, very nicely. So that's the story of a rectangle. That's the story of a rectangle. Let's practice one. Let's do another rectangle out here, all right? It says the length of the rectangle is 3. Oh, there's that less than, my friends. There's less than. And there's twice. Underline it twice. How's that? That's pretty cool. And, woo, 3 less than twice the width. So what we need to think about here, I'm going to go ahead and say W is where we're starting. But what are we going to do with that W to get the length on this picture? All right, we're going to let the W be the width. But it says twice the width, so that is 2W. And you know what we're going to do? It says 3 less than. We're going to put a minus 3 right there. We are looking for both dimensions again. That's the good news. So here we go, W minus 3. We're going to put all these sides together and a W right there. This time I'm going to use the formula. This time I'm going to use our formula. You say, what's the formula? The formula is 2 times length plus 2 times width equals the big perimeter, equals perimeter. So in this case, what we're going to do, we're going to take 2 times our length, which happens to be, by the way, we put a parenthesis in there because we're fitting in 2W minus 3. So we're going to put 2W minus your 3. Everybody good? Everybody good on that? And good grief, it's just 2W, isn't it? Because width is W. So that was easy. And this time our perimeter is 36. A little different, a little bit different, all right? That's okay. It's okay. Now, dear friends, time to distribute. Time to distribute. Everybody knows how to distribute, right? You say 2 times the 2 and don't stop there. Keep going. Take 2 times the minus 3. Got to hit them both. That's going to give us 4W. Are we ready for this? Minus 6. Plus 2W. Again, that W didn't change again. Equaling to 36. Now, piece your like terms together. I see 4 plus 2, you see 4 plus 2, I see that gives me 6W. The minus 6 is still hanging on. Folks, it's got to stay separate. It doesn't have a W, so don't mess with it. Over here, it's still 36. We haven't budged yet. We have not left that moment. Let's check on through here. This time we got a minus 6 here, so we need to add 6 to both sides. Everybody got it? Add 6, addition property of equality. Let's do it. It's going to give me 42 to the right, and on the left, I've got 6W, which I like because I know 6 divides into 42 evenly because I know my times tables. So let's do it. W equals to 7. Right there we have it. A quick check. All right, we've got saying our W is 7. We're going to put a 7 right in there for 2W, 2 times W. It's going to be 2 times 7. And that's 14, and we subtract 3, we get 11. So it looks like I'm getting 7 and 11. Well, I'm going to have an 11 down here also. Let's see if I can make an 11 happen. Goodness sakes. And over here we have a 7. All right. So adding these all up, a little 7 right there. We've got, looks like 11 and 11, which is 22. 7 and 7 is 14. My goodness, 22 and 14, it gives me, goodness, 36. So it's like saying 22 plus 14 equals 36. And that, folks, checks. So we got good dimensions. We got good values. Our dimensions, by the way, are 7 and 11. 7 and 11, all right? So, enough of the rectangles. Perimeter, fairly easy to do. Again, folks, draw a picture. Draw a picture. It makes it so much nicer, so much nicer. Let's take a look at just a good old age problem, all right? Take a look at this one. Ken and Lynn. It looks like Ken is 3 times as old as Lynn. The sum of their ages, 52. How old is Ken? All right, so first of all, who are we going to let be X or N or something here? All right, looks like Lynn is going to be a certain age. Maybe he's 5 and Ken would be 3 times that old, which would be 15. Obviously, they don't add up 52, but that's the idea. So I think Lynn is going to be our X, all right? X is going to equal Lynn's age, okay? Now, I'm going to go ahead and triple that X for Ken's age, all right? I'm going to let 3X equal Ken's age. I don't know what it is, but I certainly am going to be able to figure it out here, all right? So there's our defining of our variables. Actually, we have sort of 2 variables here. Once we get X, we know that other one is going to be triple that amount, all right? So that one works pretty easy. The next key word, sum, and there's is, all right? So we're going to add these 2 ages together, and we're going to get, looks like 52. Let's check it out and see what happens. How about we go with X plus 3X equaling to 52. Now, I got 4X because remember there's a 1 in front of that X over there. So that's going to be 4X equaling to 52. 4 divides into there evenly. It goes 13 times, doesn't it, folks? Y'all are good out there. Y'all knew that. So we're going to get 13. And guess what? That's Lynn. That's how old Lynn is. Question didn't ask about Lynn, but we're going to go ahead and put him up here. He's 13. It asked about Ken. Now, Ken is 3 times 13, which is going to give us 39. I like those numbers. I like them even better if they'll check. So let's figure it out. It says the sum of their ages must be 52. So we're going to look and see. Does 13 plus 39 equal 52? Oh, my friends, 52 all around here. It definitely works. So there's your values. So Ken, you're 39. And yes, the totals are at 52. 52. All right. Hey, folks, we want to always remind you to like us on Facebook because we love to hear from you there. It's where we get some of our comments, where we get some of our problems. And you know what? We love you to like us because we know you're here. You know you're with us. And how about it? Mathline at TNLearn.org. We're always looking for questions and commentaries, and also we'll put those on a later show this summer. Won't always have to wait till fall, all right? We're going to be doing a lot of things this summer. Now, with summer school, the way things run here, everybody keeps asking me, we missed problem of the day. Well, you'll get those back come August the 8th. They'll be back. We'll be back with problems of the day. And some of you said, well, we miss you on YouTube. Well, you know what? We're starting to get some YouTube stuff going too, and it's already out there, some of our problems of the day. But you may be seeing some full shows out there pretty soon. So you don't want to miss out on that. There it is, our YouTube, www.youtube.com. And we've got that backward slash going with TNLearn. So good place to look for us, great place to look for us. And of course, you can look for us always here every afternoon. Now, Summer school is a little bit more laid back, as you all noticed. And some days we look like we have a lot of great problems going in one direction. Other days we just may jazz it up and just pick a topic, kind of thing, or just pick a few problems that you've sent in. All right. And, that's what happens. It's on Mathline. It's kind of our own little show. We have fun with it. But you know where you can find out where we're doing each day? We tell you in advance on Facebook. So you can catch us there. And that's a great place to also send us some things. And you know what? We're trying to give you some college prep this summer, but also for you middle school guys, this is kind of what this was today, a little bit of middle school prepping to get you ready for those high school algebra years. We are here to give you a bridge, so to speak. All right. So, hey, thank you for tuning into our bridge today. Apply with care. By all means, always apply with care and things go well in Mathland. Hey, thanks for tuning in. We'll see you again tomorrow.